Hello everyone. Today we'll be looking at a rather interesting integral. Uh, and this might surprise some of you. So let's brace ourselves. We are asked to evaluate the integral from 0 to pi over 2 of 1 over 3 plus 5 cosine x dx. Now, don't be fooled by its tame appearance. Because this might actually be as simple as you guys think. There are a lot of things we could try. We could try a U substitution, maybe, or maybe do by parts. Doesn't seem like it would work out that well here. So what can we do? Well, certainly we would have not come up with this if it wasn't for some very smart people who came up with it first. So for no reason at all, we are going to let, let's write that clear. Let u equal to, let the u equal to tangent of u over. Well, what is this gonna do for us? Doesn't seem like it's gonna help, huh? Well, bear with me. We are going to try to work with this tangent of x over 2 and try to come up with the formulas for the trigonometric functions. Well, let's try to find a way to get cosine and sine then. So using this, let's try to find cosine of x over 2. And we're also going to try to find sine of x over 2 and see what we get. Well, cosine is just 1 over secant x. Right? And we know that is 1 over the square root of 1 plus tangent squared of, that's coming directly from our trig identity of our Pythagorean identity. So we can just replace that with 1 over square root of 1 plus u squared. Okay, that's one of them. Very nice. Let's try sine. Well, we know it's tangent. Well, we know that. Okay, let's think about this. We know that tangent. Okay, we know that tangent is sine over cosine. Well, all you gotta do is multiply by a cosine to get sine. So we just need to multiply. We just need to divide by 1 over secant theta to get sine theta. So let's do that. We have tangent of x over 2 over secant. And we know what tangent of x over 2 is. It's u. And we also have secant of x over 2, which is just that. So therefore we get square root of 1 plus u squared. Okay. That is all pretty useful. Not that useful. Well, you'll notice in our original problem we got cosine x, right? It's just cosine of just x. So we want this is just x. So we want to find an expression in terms of u that will also give us cosine x. So to do that, we're going to use our addition identities or double identities. So using double identities. Okay, we can find that sine of x is what? This is 2 cosine x over 2 sine x over 2. Well, what is that going to give us? This is what? 2 times cosine of x over 2. We just worked it out. It's just 1 over the square root of 1 plus u squared times sine of x over 2, which is this result, which is u over square root of 1 plus u squared. And we find that, so therefore the sine of x is just, what do we have? 2u over 1 plus u squared. Okay, nice. That's another one of our results. And now let's do cosine while we're at it. That's the one we're interested in. This is 1 minus. Actually, it doesn't really matter. We can just do let's just do cosine squared of x over 2 minus sine squared of x over 2. What does that give us? This is cosine squared of x over 2, which is this, which gives us 1 over 1 plus u squared minus u over 1 plus u squared. Well, that's nice. Cosine x turns out to be 1 minus u squared over 1 plus u squared, which is, I gotta say, is quite nice. Okay, so what now? Well, the thing we introduced in the beginning, this u equals tangent of x over 2 thing, quantity. That technically still counts as a substitution. This is technically a trig substitution. It's not an obvious one, but it still counts. So in doing that, we need to change the bounds right now. So we know this is right now as x equal to. So we need to change this into u in terms of u. So how do we do that? Well, to do that, we need to work out the differential, right? We need to work out the. So we need to work out the differential du in terms of our new variable u. That's our new variable right here. So let's do that. And we just follow the standard procedure. So we find the differential. We find that. So we get you know that u is equal to tangent of x over 2. Now we take the derivative with respect to x. And we get 1/2 secant squared of x. So therefore the differential, the du is equal to 1/2 secant squared of x over 2 dx. Well, we don't really want anything to do with x's. So we're going to rewrite this in terms of u, everything in terms of u. Actually, yeah. So we need dx by itself. So dx is what? Du. So 2 du over secant squared of x over 2. Well, what does that give us? Well, we know that secant squared of, that's the same as cosine, which is just cosine of x over 2 squared. So this is 2 du over 1 over cosine squared of x over 2. Well, what's that going to be? This is 2 du over, well, to find out what cosine of x over 2 is, we just look back at our formula we derived earlier. That's just 1 over square root of 1 minus 1 plus u squared. So this is let's put it in a different color. 1 over the square root of 1 plus u squared, all squared. Well, what do we get? So therefore, the differential for x turns out to be 2 du over 1 plus u squared.